Hey guys, welcome to the video for writing equations and converting between the forms. So we're still in Unit 7A. Our essential question is how can we rewrite equations in both standard and vertex form? So last few lessons we learned how to graph standard form and graph vertex form. Well, now we're going to learn how to convert the equations back and forth from each other. So just as a reminder, standard form is y equals ax squared plus bx plus c. Standard is always one with a, b, and c in it. Okay, the other form that you learned was vertex form, and that is y equals a parentheses x minus h parentheses squared plus k. Now, why is it called vertex form? Well, it's called vertex form because there's a vertex in the form. And the vertex is noted by the two letters h, comma, k. And remember, your h is always backwards. The number is always backwards from what it is in the parentheses, but your k is always the same. All right, so just as a reminder that a is the same in both forms. So if a is 3 in standard form, then it's going to be 3 in vertex form also. So they're going to be the exact same in both. All right, so this video is broken up into 3 different sections. The first section, we're going to convert from vertex form to standard form. The second section, we're going to convert from standard form to vertex form. And the last section, we are going to be writing in vertex form given a vertex and a point. So we will have 3 different sections of this video. All right, so convert from vertex form to standard form. Remember, vertex form is the one with the parentheses. It's the one with the vertex in it. So we're going to go from vertex form, which is y equals a parentheses x minus h squared plus k. We're going from this form and going to standard form. Remember, standard form is one without parentheses. Okay, so we're going from vertex form to standard form. Well, what does vertex form have that standard form does not have? Well, one thing, it has a vertex, right? Standard form doesn't have a vertex. But the second thing it has is parentheses. Standard form does not have any parentheses, so we have to get rid of the parentheses. So, do you remember back when we were factoring, right? You would factor by grouping, and then you would have x, and then x plus 3, and then plus 3, and then x plus 3. Right, you would factor by grouping. So in your first group, you would have x plus 3, and then you would put the matching ones together, right? X plus 3. Well, then you notice that they were exactly the same. So how did we write that if they were exactly the same? Well, I would write it as x plus 3 squared, right? Because there's 2 of them. So when I look over here where it says y equals 2x minus 3 squared minus 4, I notice that there's a 2 here, that there's 2 of the x minus 3. So the very first thing that you always do when you do these problems is you must write the parentheses twice. Okay, you're expanding it back out. We're not factoring anymore, right? Factoring was the opposite of distributing. This time we want to distribute, so we want to make it and expand it as much as possible. So the first thing I do is I wrote my parentheses twice. I didn't do anything else to anything yet. Just wrote it twice. And I'll go ahead and highlight the 2 there. Okay, the next step here is we're going to want to double distribute. Now remember, double distributing is we're going to distribute twice. So the first thing I'm going to do is I'm going to do x times 2, and I get x squared. X times negative 3 is negative 3x. And then I'm done with the x. I've finished distributing the x. Now I'm going to do the second part of the distributing and distribute the second term. Negative 3 times x is negative 3x, and negative 3 times negative 3 is positive 9. Now notice, I haven't done anything with the 2 and the negative 4 yet, so I need to keep my parentheses out there. I'm going to keep these parentheses out there, and I'm going to do y equals 2, and then I have the minus 4. One of the most common mistakes, I'll give you 2 of them. One of the most common mistakes is we forget about the negative 4 and we just forget about it in the previous step. So sometimes we just forget to write it down. We want to make sure you don't do that. Secondly, what happens if you don't put these parentheses here? Well, then it looks like 2x squared. Right? There's no parentheses. So you want to make sure the parentheses are there. I'm going to move this down a little bit. Okay. Now, what can I do? Well, I notice that there's a 2 on the outside, right? I could distribute that in. So let's go ahead and do that. So let's distribute. 2 times x squared is 2x squared. 2 times negative 3 is negative 6x. I'm actually going to move this down because I don't have a ton of room. Okay, 2 times negative 3x is negative 6x. 2 times 9 is positive 18. So I distributed the 2 to everything on the inside. Since I have 4 terms on the inside, I distributed it to everything. So then I have y equals, because I still have the y in the front. You want to make sure you keep the y there because it is an equation, all right? Now, am I finished? No. One thing I forgot is the minus 4. You don't want to forget about that. All right, and the next step is just to combine your like terms. Simplify what you have. You want to combine anything that you can. So one thing I see is that are like terms are the negative 6x and negative 6x. So I have y equals 2x squared, right? Because that doesn't combine with anything. But the negative 6 plus negative 6 makes negative 12x. And then I notice that I have like terms over here, 18 and negative 4. That's really hard to see, so let's do a lighter color. Let's do like baby blue. 18 and negative 4. What do those two make? Well, 18 minus 4 is positive 14. Now, is this in standard form? Yes. Remember, standard form is ax squared plus bx plus c. I went from vertex form to standard form. Now, what do you notice about your a values? What was your a when we started this? What was our a here? Our a was 2, right? What's our a now? It's still 2. Your a is going to always stay the same. Okay, so let's go ahead and write down the steps before we do the next problem. So the first step is you want to write your parentheses twice. Okay, you want to do that twice. That's probably the most crucial step because if you start distributing the 2 in the front first, it's going to be some bad news right there. Okay, the second step after we wrote it twice, what did we do? Well, we double distributed. Okay? After we double distributed, what did we do next? Well, I distributed all of the 2's, right? I distributed the first 2 into everything. So, distribute the a, remember that's your a, to the parentheses. Okay, remember when you were distributing, it only distributes to anything in the parentheses. So, it wouldn't have distributed to the negative 4 out here because it's just by itself. And then the very last thing was I combined like terms. Now, if you're at the step, let's say you're at the yellow step right here. Let's say you didn't want to distribute the 2 first. You don't have to. You can actually combine these 2, and then you would still get the same answer. But this way, it's less steps. So if you want to combine negative 3x and make it negative 6x inside, you may do so. Okay, moving on to number 2. So the first step says to do what? The first step says is to write your parentheses twice. So we have y equals 3, parentheses x plus 1, parentheses x plus 1, and then minus 2. So I've just noticed that I have a 2 here, so I'm going to write it twice. The next thing I'm going to do is I'm going to double distribute. Okay? X times x is x squared. X times positive 1 is positive 1x. Okay, so I'm done distributing the x. Now I'm going to distribute the other part. 1 times x is 1x. And 1 times 1 is positive 1. Okay, now I haven't done anything else yet, so I want to make sure my parentheses are still there. And then I have y equals 3 minus 2. Okay, so I'm done double distributing. Now what? Well, after I double distribute, I want to distribute the a into the parentheses. Well, our a here is 3, so we're going to distribute that inside. So we have 3 times x squared, which is 3x squared. 3 times 1x is positive 3x. 3 times 1x is positive 3x. And 3 times 1 is 3. So lots of 3's here. Okay, we don't want to forget we have y equals at the front because we haven't done anything to that. And we still have the minus 2. Okay, so we're doing one step at a time here. Again, if you need to rewind the video so that you can double check everything I did, you may do so. You have the ability to do that. And then the very last step after I'm done distributing and everything is complete, I'm going to combine like terms. So I have y equals, well, 3x squared doesn't have any like terms because there's no other x squareds in here. But I notice that I have 3x, I have 3x and 3x. Well, what's 3 plus 3? 6x. Okay, and then the other like term I have is, oh my goodness, is positive 3 and negative 2. What's 3 minus 2? Positive 1. Is this in standard form? It is. Now, here's the thing. Why are we doing this? Well, sometimes it's easier to have one form than the other, right? So here we have vertex form, and I have transformed it into standard form. If I were to graph this equation, the very original one, and the one that I just have now, I would get the exact same thing, the exact same graph, and I will show you. Okay, so I have y equals 3, parentheses x plus 1, parentheses squared, minus 2. And then I have y equals, now this is the new one that we converted it to, 3x, and I'll go ahead and do projector mode so you can see a little bit better. 3x squared plus 6x plus 1. That's exactly what we have, right? That's exactly what we have when we transformed it. We went from the red one to the blue. But notice how their graphs are exactly the same. So again, we're just converting the forms, but they are the exact same graph. So these were my two that I got on the front page. So that's our practice with going from vertex form to standard form. So I'm going with something that comes from parentheses, and I'm getting rid of the parentheses. But remember, your A is always the same. All right. Now we're going to convert from standard form to vertex form. Okay. Now, standard form, again, remember that is y equals ax squared plus bx plus c. So I'm going from that form to vertex form, which has parentheses. A parentheses x minus h squared plus k. And remember, it is called vertex form because it has a vertex in it. So in order to write an equation in vertex form, you need the vertex. Right? If I don't have the vertex, how am I supposed to write it in vertex form? Well, there's a formula I showed you that you can find part of the vertex. And how? Well, you're going to use the axis of symmetry formula. Okay? That formula is x equals negative b divided by 2a. So let me go back to when we talked about this. So you're going to graph, look, so here we're given an equation in standard form, 2x squared minus 8x plus 8. And I'm asking you to find the vertex without graphing it, right? Well, how did we find this vertex? Well, we used the axis of symmetry formula, right, to find the x, and then I found the y by plugging in that x. So we're going to have to do the exact same thing here. We're given an equation in standard form. Okay, so we do not know the vertex unless we graph it, but we can't graph it. We need to find it by hand. So let's go ahead. The first thing I want to do is find the vertex. I have to find that. In order to find that, I got to find the axis of symmetry because that number is going to be the x value of my vertex. So here we go. The first thing to do to use the formula is to identify A, B, and C. Your A here is 3, B here is negative 12, and C is positive 1. Now, do I need the C value? I do not. Okay, so this is my A, B, and C. All right, well, now we're going to use the formula x equals negative b divided by 2a, right? And I think I'm going to change the color of this to blue. Okay, so we're going to plug it in. Oops. X equals negative, what's my b? It's negative 12 divided by 2 times my a, which is 3. And I simplify this, I'm going to have positive 12 in the numerator and positive 6 in the denominator. And that equals 2. So x equals 2. So what does that tell me? That tells me that my vertex, the x value is 2. But I don't know the y value. So how can I find it? Well, I'm going to use the equation at the top. Y equals 3x squared minus 12x plus 1. If I know the x value of the vertex is 2, then to find the y value, I would plug in the x value. So anywhere you see an x, you're going to plug in a 2. All right. So then you have y equals 3. Parentheses, you always plug in using parentheses, 2 squared minus 12 parentheses 2 plus 1. Now, if I type this all into the calculator exactly how I see it, 3 parentheses 2 parentheses squared minus 12 parentheses 2 parentheses plus 1, I'm not even sure what that is, actually. So I'm going to go type it in. So 3, 2 squared. I should get a number. Whoops, minus 12 parentheses 2 plus 1. And my number is negative 11. Okay, so that means my vertex is 2, negative 11. I'm going to double check to make sure I typed in everything correctly. 2 squared minus 12, 2 plus 1. Perfect. Okay, so that is my vertex. But is that what they wanted me to find? Is that what the goal of this section was? No, I want to create an equation, right? I'm trying to create an equation from standard form to vertex form. Well, right now, all I have is the vertex, okay? So what is vertex form? Well, vertex form is y equals a, parentheses, x minus h squared plus k. That is vertex form. Well, what do I know now? I do know the vertex now, right? I know that it's 2, comma, negative 11. So let's go ahead and plug those in, okay? So let me remind you, when we write equations, what 2 variables are always present when we're able to graph them? There's always an x and there's always a y. So when you write your equation, there should be an x and y left over, right? Like right here, what variables do you see? Just x and y. What variables do you see in the original equation? Just x and y. So when I'm writing this equation, I'm not plugging anything in for x or y. So I have y equals a, parentheses, x, right? I'm not plugging in anything for x and anything for y. But do I know my h now? Remember, my h is part of my vertex. My h is going to be negative 2. It's positive 2 here, but when I plug it in, it's going to be negative 2. Squared plus k. Well, what is my k? It's negative 11. Now, is this vertex form? Close, right? What letter are we missing? The a. Remember, every equation has to have an x and y, and that's it. They shouldn't have any other variables in there. So what is our a value? Remember on the very front page, I said that a was the same in both forms, right? If a is 7 in standard form, then a is 7 in vertex form. So what is our a value of this equation? It is 3. So if our a is 3 there, then it's also going to be 3 here. 3, parentheses, x minus 2 squared minus 11. Is this now in vertex form? Yes. So how can you check this to see if you're correct? Well, I'm going to use Desmos to check this. So the original equation I have is 3x squared minus 12x minus 1, I believe. Y equals 3x squared minus 12x minus 1. Is that right? Plus 1. Plus 1. Okay. And then in vertex form, I have the 3x minus 2 squared minus 11. I'm going to zoom out a little bit. Are the green and the purple the same? They are. Remember, the green is what we started with, and the purple is what we ended up getting. So how did I get the h and k? How did I know what to plug in for h and k? Well, I had to find the vertex by using the formula, right? It doesn't tell me that. This one is not as obvious as the last one. The last one was like, okay, I just keep distributing and distributing and distributing and combine like terms. This one I have to use a formula, then I gotta plug stuff in, and I gotta make sure the a is there. So you wanna make sure that all of these little things, that you pay attention to each little step that we take here, right? So how did we get to negative 11 in the equation here? I had to find the vertex using the axis of symmetry formula. Okay, well, where did the a come from? Remember, the a is part of the original. We got the a from the original. If a is 3 in standard form, then it is going to be 3 in vertex form. So let's go ahead and write our steps here. The first step is use the axis of symmetry formula to find the vertex. Okay? After we found the vertex, right, I want you to write out vertex form. That is going to be y equals a, parentheses. Whoa, that was weird. y equals a parentheses x minus h squared plus k. I want you to write out that formula. Okay, and then we plugged in some numbers. What numbers did we plug in? Well, we plugged in 3, 2, and negative 11. So what variables did we plug in? We plug in our a value, our h, and our k. What values do we never plug in for? X and y. We don't want to plug in for x and y because we want that to be in our equation. Okay, so you plug in a, h, and k. So we're going to use these steps to do the second one. All right, now after I finish the second one here, I am going to stop the video and do the last page in a separate video, just so that the video isn't too long. All right, so number 2, y equals 2x squared plus 12x plus 14. This is in standard form. The goal is to get it to vertex form. In order to get it to vertex form, I need to find the vertex. So the first thing I'm going to do is identify a, b, and c. A here is 2, b is 12, and c is 14. And then I'm going to use the formula. X equals negative 12, negative b, right, divided by 2a. So 2 parentheses 2. Well, that's going to give me negative 12 divided by 4. So x equals 3, or negative 3, I'm sorry. That is your AOS. So we actually haven't found it. That's just our axis of symmetry. But what do I know about my vertex? Well, I know the vertex will have the point negative 3, but I gotta find the y, right? I don't know the y part yet. So that's something I gotta find. Well, how can I find that? I'm gonna use the original equation. So this part should be reviewed because we learned this previously already. I'm gonna use the original equation. If I know that x equals 3, I'm gonna plug in, or negative 3, I'm gonna plug in negative 3 for anywhere I see an x. Y equals 2, and always use parentheses, negative 3 squared plus 12, parentheses, negative 3 plus 14. Okay, and I should get negative 4 from this, but I am going to double check in my calculator. Oh my goodness, squared plus 12, negative 3. I keep making a mistype, so I'm sorry. Yeah, it is negative 4. So y equals negative 4. Okay, so all of this equals negative 4. All right, negative 4. So my vertex is negative 3, negative 4. So is that what they wanted me to find? It's not, right? That's not what they wanted me to do. They want me to write an equation in vertex form. Now that I have the vertex, right, the second step is to write out the equation. So I'm going to write it out. So vertex form is y equals a parentheses x minus h squared plus k. All right, that's the form. Now I've written it out and it says to plug in a, h, and k. Okay, so I have y equals, because I don't plug in anything for y. Well, what's my a going to be? Well, remember, it's the same as the a in standard form. So what was my a here? It was 2. So I'm going to plug in a 2 for my a. Parentheses, do I plug in anything for x? No, you want to keep y and x there. Well, what's my h going to be? Remember, that's the x value of your vertex. So it's going to be positive 3. Why is it positive 3? Because it's opposite signs. Okay? And then I have plus k. Well, what is my k here? It's negative 4. Is this now in vertex form? Yes. If I were to graph that equation and the original equation in Desmos, they're going to be the exact same graph. I'm just going from form to form. So, was the first page similar to the second page? Not really, right? There's a lot more work in the second page. There's a lot more thinking involved. On the first page, if you're going from vertex form to standard form, you're getting rid of the parentheses. So you're distributing a lot, you're combining a lot of like terms. This is typically the easier one to do, going from vertex to standard. The harder one is going from standard to vertex. With standard form, they don't really give you much, so you have to find the vertex. To find the vertex, you got to use the formula. Once you use that formula, you're going to plug in your a, your h, and your k. Remember, hk is your vertex, the thing that you just found, and then the a is the same a as in the original, which was your 2. A is going to be the same. All right, so that is the first 2 pages, and I'm going to do the last part of the video in a separate video. If you have any questions, please feel free to come in for tutoring.